In this lecture, we are going to write our own program to find the factorial of a number by using recursion. Generally, factorial of a number can be found using two different ways. One is the iterative way, and another one is the recursive method. So let's first of all discuss how we find out 5 factorial using the iterative method, using the iterations or by using a loop. Okay, so 5 factorial, as you know by the definition of factorial function, is that I multiply 5 with 4 with 3 times 2 times 1. So I start the multiplication starting from I equals to 5, okay, to I equals to 1. I multiply all these numbers to finally get the answer as 120. So this can be easily achieved, and we have already done this problem by using a loop. So I can run a loop starting from I equals to 5 and up to I equals to 1, and I multiply all these numbers together to finally get my answer, which is 120. This is called as iteration. I am running a loop, right? I am having an iteration. In each iteration, the value of I is updated, right? Initially, the value of I is 5, and then the value of I is updated to 4, and then 3, and then 2, and then 1. I multiply all these numbers to finally get my answer, which is 120. So this is iterative way. Now let's see how we can find 5 factorial using recursion. 5 factorial can be written as 5 factorial is equals to 5 times 4 factorial. Now I need to find out 4 factorial and multiply that with 5 to get the answer, that is 5 factorial. Now what is 4 factorial? 4 factorial can be written as 4 times 3 factorial. How do I find out 3 factorial? It is nothing but 3 times 2 factorial. Now how do I find out 2 factorial? I write 2 times 1 factorial. Now I actually know the answer of 1 factorial. That is the known fact. I know that 1 factorial is always equals to 1. This is a fact, right? Because now I already know that 1 factorial is 1, I do not call this factorial operator one more time. So I stop calling factorial operator at this point. Now I know that 1 factorial is 1, so I can replace this entire 1 factorial by 1. So 2 times 1 is 2. That means this was called by 2 while finding 2 factorial, I called 2 times 1 factorial. That means the answer for 2 factorial is already found out, which is written back to this one. So 2 factorial will now be replaced by 2. So 3 times 2, the answer is 6. Now I have already found out the answer of this entire 3 factorial, which was 6, right? So I written 6 to this 3 factorial. So 3 factorial becomes 6. 6 times 4 becomes 24. Now 24 is nothing but 4 factorial, because this is 4 factorial, right? So I'll return 4 factorial answer 24 here. So 24 times 5 becomes 120, and 120 is my answer. Now this way of finding the factorial of a number is a recursive method, okay? And this is the iterative method. Now we're going to write a program to find a factorial of a number using a recursive method. But before we do that, let's try to write down the function, a recursive function, a mathematical function. Let's say f denotes my recursive factorial function. So I'm trying to find the factorial of number n, right? Now I'm very much guaranteed that if n is 1, 1 factorial is always 1, right? So factorial of 1 is 1. So I write fn would be 1 if n is equals to 1. If n is 1, 1 factorial is 1. So factorial of 1 is 1. That is, factorial of 1 is 1. Okay. In other cases like in this 5 factorial is how much? 5 times 4 factorial. 4 factorial is how much? 4 times 3 factorial. So I can say n factorial is nothing but n times n minus 1 factorial. So this is the formula to find n factorial. So if n is something other than 1, then fn or factorial of n is nothing but n times factorial function f of what? N minus 1. Okay. If this is true only if n is greater than 1. So this is my recursive equation. This equation will help me to find the factorial of any number. Okay. So with this note, let's try to write a program for the same. Now before we write the function to find the factorial of a number, that too the function should be a recursive function. What we need to understand is what would be the input or the argument for this function. So first of all, let's write down the name of the function. Let's say the name of the function is fact. Okay, now what would be the input for this function and what would be the return type of this function? Now this factorial function, because I need to find a factorial of a number, right? So it will take a number, integer number n as the argument. So I'll write int n because I'm trying to find the factorial of n. Okay, now what is the return type? The factorial function should take the number and return back the factorial of that number. So factorial of a number, let's assume it to be the integer number. So I write int. So return type is int, name of the function is factorial, and the argument is n, which is the integer value. Okay, so first of all, we need to write down the code for the base condition. We have already noted down the base condition. Base condition is this: whenever n is 1, okay, this is the base condition. Whenever n is 1, 1 factorial is how much? 1. Okay, because we know that 1 factorial is always 1. So what I write here is, if somehow n happens to be equals to 1, I already know what is the answer for this, right? The answer is clear, and that is the fact. The answer for this is 1. So I just return the value 1 to whoever calls this function. Okay, so this is the base condition. So let me write down, this is the base condition. Whoever calls to this function by passing the value of n as 1, you return the answer as 1, because I know that 1 factorial is 1. Else what do I do? Else the value of n is something greater than 1. I'm in the else case, which is represented by this equation. So now I need to find the factorial of n. So how do I find out the factorial of n? So factorial of n is nothing but n times, I need to call the same function fact of n minus 1. Okay, so what I'm trying to do is I'm making a call to the same function, to this one. Okay, so I need to return this. Once this calculation is done, I need to return this to wherever it is called from. Okay, so this entire thing is the code. This is very simple code, right? This code will help me to find the factorial of a number, but this is done in a recursive way. Okay, so let's try to trace this code now. So this is the function to find the factorial of a number. Let's assume that I would like to find the factorial of 3, that is 3 factorial. So I'm going to make a call to this function in the main function by making a call fact3. Okay, so this will make a call to this function. So whenever I write fact3, so whenever I make a function call to fact3, what is going to happen is, it is going to go in the else part, because 3 is not equals to 1. It will go to the else part. So it will run this statement. What is the statement? The statement is return n times, n is 3, 3 times fact of 3 minus 1 is 2, fact of 2. Okay, now fact of 2 is again a call to the same function factorial. So whenever n is 2, what happens is 2 is equals to 1 is false. It will go to the else part. So this will make a call to return. Okay, this statement is executed. Return n is 2 times fact of n minus 1, that is fact of 2 minus 1 is 1. So fact of 1. So now fact of 1 will again call the same function, factorial function. Okay, the argument n is equals to 1. Okay, it will call the same functions. So it will go to the if part and check the condition. If n equals to 1, is n equals to 1? Yes, n is equals to 1 here. So it will go to the if part and it will return 1. So this entire thing will be now evaluated, and the answer 1 would be returned to this particular place. Okay, so this entire thing would get the value 1. So once value 1 is received by this part, now this statement has received all its value, right? This operator multiplication has received the left hand value, and also right hand value is calculated, which is 1. So this statement is now finally going to be completed. So it will be executed, and the multiplication, answer of the multiplication is 2 times 1 is 2. So this is as good as 2. So it is as good as return 2. So this entire thing is replaced by 2. Okay, so now it will return 2 to wherever it was called. So this was called at this point, so this will be receiving the value 2. So this entire thing becomes 2. Okay, now because for this return statement, this left hand operand for multiplication is received, right hand operand is 2, right? So 3 times 2 is 6. So this entire thing is now calculated to 6, and once this is done, this 6 is returned back to whoever called it. So this was called by factorial of 3. So factorial of 3 would be receiving the answer as 6, and this is my final answer, because I know that 3 factorial is equals to 6. So this is how you use a recursive function to find the factorial of a number. Now let's write down a program to demonstrate the same. Now this is a program to find out the factorial of a number n using recursion. Okay, so here I need to first of all write the factorial function. Now what is the input for this factorial function? We have already discussed, to find a factorial of a number, you will be needing an integer number. Let's say the integer number is n. So the type is of integer. Okay, what is the return type? What do you return once the factorial is found out? You have to return the factorial of a number, right? So factorial of a number is again an integer number, so I'll return the factorial of n, which is also an integer number. Okay, now what is the base condition? Always you have to think of the base condition whenever you are writing a recursive function, because base condition will help you to converge and you finally reach to the output. Okay, the base condition here is if n equals to 1, I return the answer as answer is equals to 1, because 1 factorial is 1, because 1 factorial is 1. You can also make 0 factorial as the base condition, because I also know that 0 factorial is also 1. Okay, but we'll stick to 1 factorial is 1. Okay, we need not go up to 0. Okay, so this is the base condition. Now let's write down the function. So let's write down the return type is int, name of the function is factorial, or let's write fact. Okay, argument is n, which is the integer value. Okay, then first of all you have to write the base condition. So let's write down the base condition here. What is the base condition? If my number n is equals to 1, that means I know that the answer is 1, so I return the value 1. Okay, because I know that 1 factorial is 1. Else what do I return is I return n times factorial of n. So here I am doing recursion. I am actually calling the same function factorial one more time here in line number 16. It's very simple. Therefore recursion is very simple to write than the iterative solution. Okay, so this is how you write the recursive function. Now you can actually call to this function, right? You can ask the user, let's say the number is num. Let's take the number from the user. So the number is scanned now. Okay, now what I need to do is I need to store the answer, or I can directly print the answer also. I can just printf factorial of %d is %d, right? So I have to now give comma, and what does %d, first %d refer to? The first %d refers to the number num. Okay, and what the second %d refers to? So here I'll make a function call. I'll make a call to fact by passing the argument as num. I'm trying to find the factorial of num, right? So that will be displayed here. So just save this program and then you need to compile this to get your answer. Now let's try to compile this code and see if it works fine. Let's run this now. Enter your number 3 factorial. I did not get any answer. Let's see what happens here. On providing 3, I did not get any answer, right? Maybe something is wrong here. What I've done here is, see, I have to make this as, at line number 16, I have to make this as n minus 1, because factorial of n is n times factorial of n minus 1, right? So let's make these changes and let's come back and compile this code one more time. Compilation is done successfully. Run this 3. So factorial of 3 is 6. Now it is working fine. You give any number, it should work fine. Factorial of 5 is 120. Factorial of 8 is 40320. It works fine. Okay, so I hope in this lecture you have learned how to write a factorial function on your own. That is a recursive factorial function. Okay, how to decide what would be the base condition for a factorial function. Okay, because base condition helps us to converge into the answer, and it will avoid the function to go into the infinite loop. And we have also learned how to trace any recursive function. We have already traced factorial function. Okay, so that's all in this lecture. Now in this lecture we have learned about factorial function, but factorial function is not really a good example to understand recursion well. Okay, I'm going to solve one more interesting problem using recursion that is going to help you to clear most of your doubts on recursion. Stay tuned for that interesting lecture which is coming up next.